If x and y are random variables, we define the coefficient of correlation to be the coefficient of correlation, usually just called the correlation, satisfies the following properties. It's always between -1 and 1, and the only time it can be plus or minus 1 is when one variable is a linear function of the other. So let's consider a few discrete cases. Suppose x and y are discrete random variables with PMF. Let's find the correlation of x and y. So a useful strategy as problems get more complex, focus on the questions you can answer, not the answer to the question. So we have a PMF, and that means we can find things like the expected value of x, y, and the variance. So let's go ahead and find those first. So the expected value of x will be and the expected value of x squared will be and so the variance is likewise the expected value of y, the expected value of y squared, and the variance. And finally, we can also find the expected value of the product. And so our covariance will be, and now that we have all this, we can find the coefficient of correlation because we have the covariance and the two variances. And so that will be or suppose we have m and n random variables and we have the variances and the correlation. Let's find the variance of the sum. So the variance of the sum is the sum of the variances plus twice the covariance, but we don't know the covariance. But we have the correlation, which includes the covariance. So substituting our known values of the correlation and the two variances, then solving for the covariance gives us, and that tells us the variance is, or let's take a more complicated example. Suppose in a year, the probability of an automobile claim is 0.1 and the probability of a homeowner's claim is 0.05. The correlation is 0.3. Let's calculate the probability there will be both an automobile and a homeowner's claim, and we'll assume there can be at most one automobile and at most one homeowner's claim. So again, let's focus on the questions we can answer and not the answer to the question. Let x be the number of automobile claims and the number of homeowners' claims. We can find the expected value of x, x squared, and the variance. And the expected value of y, y squared, and the variance. Since we know the correlation and we have the two variances, we can find the covariance. Now, the covariance is a formula based on the expected value of the product and the product of the expected values. And we know 3 of the 4 terms, so we can find the expected value of the product. But the expected value of the product is the sum of the products of the payoffs and the probabilities. And all of these terms, except for the last, are 0. Because except for that last one, they all include a factor of 0. And so the expected value of the product is going to be the same as the probability that x is 1 and y is 1. And we know that expected value.